All right, continue on with the first example B. If I take 12 and I split 12 into its factors, I think probably the easiest factor to pull out would be 2. And it's weird we say pull out the factor of 2, but 2 times 6y definitely gives you 12y. Now, if you notice in the circles, we can pull out our factors. So I think that if I have 6y, well, this is what I'm going to do. I'm going to split this up 6 times y, if that's okay with you. Right? Y is just a factor. What are 2 items that multiply to give y? Well, y times 1. And that's really the only factors that do so. And thus, that's what makes it really prime. Now, I'm going to split up 6 into 2 factors, and that's 2 times 3. So all I have to do is take a look at the circles to get 12y is really 2 times 2 times 3 times y. Or if we're writing it as a factor, 2 squared times 3 times y. Now, we don't really have to do it this way. This way is equally beneficial, I hope anyways. So we can take out factors. Now here, let's go on to 15xy squared. What factor am I going to take out? Well, it's really up to you. You have a choice because there are many factors. I'm going to take an easy choice. I'm going to factor out 3. If I factor out 3 out of 15xy, I'm left with 5xy squared. And now if I take a look at this, 5xy, what would you factor out? Me, I'm going to continue on with the numbers, just the numbers, and that's a-okay. So, and I'm breaking this up using a factor tree. But now I have xy squared, and I need to pull out a prime factor. Well, x would be a prime factor. X times y squared gives me xy squared. Now, what 2 items multiply together to give you y squared? Well, it's y and y. So really, 15xy squared, I can think of that as 3 times 5 times x times y times y. And in fact, what does y squared mean? It really means y times y. All right. Now, I'm going to go on to the greatest common factor for a polynomial is the largest monomial that is a factor of each term. All right, so in essence, what I'm going to do is I'm going to factor this term, and then I'm going to factor the next term, and the greatest common factor is the largest monomial that is a factor of each of these. So it just so happens that when I take 8x, I can factor out 8x as 2 times 4x. And I can factor 4x into 2 times, getting a little bit ahead of myself, as 4 times x. And then I know that this is, 4 can be split up into 2 times 2. So I have prime factors of 2, 2, 2, and x. Now I'm going to factor 10. 10 can be factored into 2 and 5. Those are its only prime factors. So the GCF, the greatest common factor, are those factors that are common to both the terms. And that is really 2 and 2. So that's my GCF, is 2. So I could write it as, now isn't that interesting? There we are. I am just going to highlight our greatest common factor is 2. And I can conclude that 8x plus 10 is 2. So I'm going to remove the GCF. 2 times what gives me 8x plus 10? Well, that is going to be 4x plus 5. Now, why is it 4x? Because it's 2 times 2 times x is what's left in the first term, and then 5 is just left over in the second term. Furthermore, if we, now remember, what two quantities multiply together, or what quantities multiply together to give you 8x plus 10? If you multiply these out, what you should get is where you started from. All right. I ask myself, what is the greatest common factor here? And the greatest common factor of term 1 and term 2, I would argue, is 3. 3 is a factor of 12. 3 is a factor of 15y. And often we do look towards the constants. So I can say this is going to be 3 times 4 minus 5y. Now, I'm going to give you a little bit of heads up here when factoring. Factoring out is very, very, very similar. It is similar to dividing. So, if you're wondering how I'm getting the second term, once you have identified your greatest common factor, may I ask you 2 questions? We have a binomial. What is 12 divided by 3? 4. What is negative 15y divided by 3? Negative 5y. There we have it. All right, let's go on to C. And for C, we are going to be looking for the GCF. So I'm going to look at it, and my brain has been trained by algebra many years, right? So I can look at the constants separately from the variables. What is the greatest common factor amongst the constants? 9 and 4. Well, the greatest common factor is actually 1. They share no common factors other than 1. What is the common factor between w squared and w? W. So the greatest common factor is really w. So when I factor this, I'm going to just put my greatest common factor in front. And then if I remove this, 9w squared divided by w is w, 9w, pardon me. And then 4w divided by w is 4. Now, I'm not dividing, but I'm doing something incredibly similar to dividing. So maybe try these next 3 by yourself and see what we come up with.